Question 6. This question is about isomers with the molecular formula C5H10O. And it says, draw the skeletal formula of a branched chain aldehyde with molecular formula C5H10O that is optically active. Now, I really don't like these type of questions where it's a one marker, but you know they add loads of them. Like in just this question, we've got two. This is very similar to it. Draw something for 2 marks instead of 1, and then another one here, 2 marks for drawing 2 cyclic isomers. But if we break down the question, so we need a skeletal formula, so we're going to use sticks. A branched chain aldehyde, well, aldehyde has a positional functional group at the end of the carbon chain with molecular formula C5H10O that is optically active. So optically active, therefore it must have a chiral carbon. And what's a chiral carbon? A chiral carbon is a carbon that has 4 different groups attached to it. So it's going to look something like this. And it's got, you know, C double bond O at the end. Because remember with aldehyde, so it's at the end of the functional group. C double bond O is always at the end of carbon chain. And then we have a methyl group here. So that's 1, 2, 3, 4, 5 carbons. We have the 10 hydrogens and we have the oxygen. And this is going to be the chiral carbon because it's attached to 4 different groups. Then it says 6.2. Describe how you can distinguish between separate samples of 2 enantiomers of the branched chain aldehyde C5H10O. Now this question, it doesn't sound that straightforward, but it's pretty straightforward as long as you know about the enantiomers and the like. So all we're going to do is use plain polarized light, and this will rotates the plane off in opposite directions. So we want to use plain polarized light, and this rotates the plane off in opposite directions, and therefore we can easily distinguish between the separate samples of the 2 enantiomers because it rotates the plane off in opposite directions. And then 6.3, draw the E and Z forms of a structural isomer of C5H10O that shows both optical and geometric isomerism. Okay. So first things first, draw EZ isomer. We're going to have C carbon double bond C in the middle. Now let's not overthink this. We've got a H here. Remember the E isomers, they're enemies. So the 2 groups are opposing each other. So we can have a hydrogen here, we'll have a hydrogen here. Makes a lot of sense. And then we'll have a methyl group here. And then what's left? Well, we've got 1, 2, 3 carbons. So we need another 2 carbons. 5 hydrogens. So we need another 5 hydrogens. So we can say CH3 and then OH group. And this is an E isomer because these 2 are enemies basically because they're opposing each other. And for Z isomer, they need to be on the same side. So exact same thing, C double bond C. But in this case, we'll have the hydrogen here, we'll have the CH3 here, and then we'll have the CH3 OH here. So C double bond CH, CH3, CH3 there, and then the CH3, C double bond CHH, CH3 OH. That's the end of question 6.3. And 6.4, isomer J is cyclic. Yeah, I can clearly tell because in this format, and has an ether functional group COC. Isomer J has only 3 peaks in its 13 carbon NMR spectrum, Draw 2 of the cyclic isomers of C5H10O that have an ether functional group and only 3 peaks in the 13C NMR spectra. Only 3 peaks. Okay, so what shape is this? Well, this has got 1, 2, 3, 4 sides. This is a rectangle. However, these two, we can make these two part of the shape. So that's the first cyclic isomer. So the first cyclic isomer probably makes the most sense. What we're going to have here, here, and an oxygen here. So we've added these two sticks on. So instead of a rectangle, we now get 1, 2, 3, 4, 5, 6. We get a hexagon, 6 sides, with the oxygen still in the middle. The second cyclic isomer of C5H10O is, well, these two sticks. Now we can put them here. That's all we're going to do. We're going to move them there. So we're going to have here, oxygen here, there, there, and there. And we've got 2 sticks sticking out that were originally here, but we just moved them there. So we've got this hexagon shape with the O in the middle, and we've got the O in the middle, same square shape, 4 sides. However, you've got the 2 sticks now, one on the opposite ends of the square. And that is the end of question 6.